Recently I got a new laptop and I've been playing Halo. How good is Halo? I never got into it when it first came out, but 20 something years later, driving around in Warthogs, it really is quite a kick. So given that I'm now a Windows maximalist, this DirectX API is looking pretty good. But there's a problem. A lot of these Windows functions that I'm going to need to use in my programming have weird types like HWND or LPSTR, LPWSTR. What's that? Well, I know what an LP is. This one's my favorite. Black metal from Japan. That got way off topic. So what I want to do in this video is I want to have a look, sort of like in my Web GPU series, how I started with the basics like Node.js and TypeScript and then went on to the Web GPU. I want to take a few videos just to look at Win32 programming. I'm going to cite my sources. What I'm doing here is I'm working through Microsoft's official tutorial on Win32 programming, cross-referencing it with Microsoft's documentation, adding a bit of insight and just working through it. Nothing too crazy. Let's get into it. Hello! So, let's get into this. Is this a little too on the nose, this Windows background? I don't know. Okay, so what I'll do is we'll just go ahead and open up Visual Studio, and I'm just going to go ahead and create a new project. Okay, we'll just make an empty project, C++. That is totally fine. We'll pick a place for it. I usually like to have a dev folder, and I'll just put that in there, and I'll say I'm going to call it project. Okay, that's probably fine. Alrighty, so I'll bring this over, make it nice and big, and I'm just going to hit this button here to show the actual files in the project. Just going to go ahead and make a folder, which I'll call src for my source code, and then in there I'll make an item, and I'll just call this main.cpp. It really doesn't matter at all. Oh, side note, I'm using the Claudia IDE extension. Is this a little too on the nose? I don't know. Jury's out. Well, in my case, maybe the jury's not out. Maybe it's multiple convictions. But anyway, so this is the basic idea of what we're going to do. We're going to have, I'll say, really just one include. Then we're going to have a main function, and the main function is going to make a window. We're going to have our main loop, and I'll leave that there for now. Actually, let me just make, what I'm doing here is I'm sort of just mocking this up so that it's easier to see at a glance how this thing's going to work. What we're going to do is get an event, and then our window, when we create our window, is going to have sort of a callback function. So we'll have a callback function like this, and inside that callback function we're going to handle an event. So we're going to need to take in some sort of event like that. And what we're going to do is we're going to send that event to our callback function. So when we make the window, we're going to give it our callback, and then I guess we're going to return 0. Okay, this is the basic idea. This is all we're going to do today. So let's have a look at that includes. So the file which we need to include is suitably named Windows. Windows.h. Okay, excellent. Now, as we can see here, the callback is being referred to in the window. So it would probably help to define the callback before the definition of the window. If I still wanted for some reason to define the callback after, I would just forward declare it. So I would put my function prototype before my main function. Okay, so now things are going to get a little strange. So this callback is going to need to return something. And what it's going to return in Windows is called an L result. Okay, so L stands for long because Windows is using Hungarian notation. That's just a historical artifact. So this is going to be a result, and yeah, as we can see here, that's sort of a long pointer. So what we mean by long pointer is it's a number which can either be treated as a pointer or a long number. So a 32-bit integer, a 64-bit integer, we can think of it as like a specific code which represents an event. Okay, so we're going to return one of those, and in order to register this as a callback function, we also need this callback macro. And this callback macro defines the calling convention of the function. So this can define things like the order in which the parameters are taken into and out of registers and things like that. So in addition to the event which we've been given that we need to handle, we also need to know which window generated that event. And in Windows programming, this is called a HWND, or a handle to a window. But there's no reason to be beholden to this old style of naming things. We can just call it window. That's fine. It's an opaque data type. So if you've worked with OpenGL or Vulkan or a lot of different APIs, you'll be familiar with handles. Handles are essentially integers. And under the hood, the operating system has some sort of indirection method, some sort of way of like, if you give me this integer, I can look it up and I can associate it and know what thing you're talking about. But just think of this as integer codes which represent objects. So we have that, and then we have this event, which is represented with an unsigned integer, which is represented with an unsigned integer, and I'm actually going to go ahead and call this a message, not an event. Okay, so now we come into the part where we have a few more fields here. We have this W param and L param. Okay, these types here. Now, what this means is depending on the type of message which is generated, additional parameters may be stuck onto the message. And in order to keep it as generic as possible, it's just a bunch of fields according to format. So W stands for wide or wide character, in other words, Unicode parameters in Unicode form, like strings, basically 16-bit character strings. And L is 64-bit unsigned integer parameters, which, yeah, anyway. So I'm going to keep this suitably generic. I'm just going to call this wide parameters and long parameters. But all of the examples that I'm working with here, we're not going to use these parameters, but we do need to specify them for the prototype. Okay, now, as far as handling the event, the way I'm going to handle the event is with a switch statement. So I'm going to do a switch based on the message. And for my, default, I'm just going to code this in. I'm going to return, this is the default window procedure. And I'm just going to pass this along. It's going to pass along my window, my message, and those extra parameters. Just like that. So I'm going to worry about different event types later, but for now, That's just, it's a functional callback. Okay, and it does nothing. It's a no-op. Okay, so how does this main stuff work? Now, this is a little bit funky because we can't simply have a main. We need to define this in a certain way. So we are going to return an integer, but I'm also going to use the macro win API, which again defines the calling convention for this. And there's a certain name that we need. I'm going to use wide win main. That's just under the hood, the main entry point. When I make a Windows program, it searches for a function like this. I think it's win main and wide win main, like that. So when the main function associates this as my entry point, it passes along a bunch of things which I have available to myself. One of those is the instance, and this is basically a handle to the program as a whole. And then we have this other one, which is called previous instance. But for historical reasons, we need to include this. In practical cases, it is always 0. It's just the craft of history, basically, that we sort of have that in there. And then the next thing, this PW, this power string. Now, what this is, the P stands for pointer, and it's a pointer to a wide string. So again, it's a single big Unicode string, and this is essentially my command line arguments. So I'm just going to call that argv. And then we have another code, and this code is pretty much declaring the way that we want this window to appear. So I'm just going to call it appearance. Okay, so it's a bit of a funky thing here. Making the window actually has 2 steps. One step is we need to register a window class, and then the second step is we need to actually create a window. Now, the reason we need to register a window class, even though if you think of the traditional meaning of a window, it's like a pop-up, but in Windows, it's not. In Windows, everything is a widget. So a window is a widget. So for instance, if you have a button, if you have a slider, that counts as a window. So in this case, our window really is a window, but we need to register that window class, sort of like creating a custom widget, which is the program, and then we'll instantiate it. So there are a few things involved in this. One thing I need to do is I need to define the name of the window, the window class, sorry. And this is with the wide character type, which I'm going to call class name. Yeah, just call my window class. This L is defining Unicode character, literal, basically. And then I'm going to basically create a window class struct and populate it. So I'm going to go ahead, okay, window class, going to 0 that out to start with, give everything a sensible default value. Then I'm going to set some properties of it. So I'm going to go, hey, window class, your window process, the callback, this is with the long pointer function window procedure, sorry, not process. So I'm going to set that to my callback function above. Then we have the instance. By the way, I forgot to mention, why do we call these things long pointers? Well, it's a historical issue, mainly. Back in the day, there were like old, like, you know, MS-DOS 95 sort of, you know, Windows 95 sort of times. the computer actually it didn't have access to like a 32-bit address size in its RAM. They had 16-bit pointers. That was it. And like when Wolfenstein was made, by ID Software, they had to use tricks. You had to use tricks to access that full 32-bit address size in RAM. But then along came 32-bit pointers, and they were bigger, and so they were called long pointers. Now, the thing with Windows code is I can write this code right now, and I can compile it to either 64 or 32-bit. It actually doesn't matter. Whatever I'm compiling for, the pointer size will change accordingly. But by convention, these are called long pointers. There we have it. Okay, so the next thing is I'm going to need to set my class name. So go window class. Here we go. Long pointer size, string, something. Anyway, and I'm just going to set that to the class name. These class names can have spaces, by the way. That's totally fine. It just needs to be a unique identifier. Okay, so here I'm going to register the class, and it says here that I need to provide a long pointer to a window class. That's no problem. I constructed a window class, so I'll just get its address and pass that through. Side note that this register class has come in purple, so it's actually been recognized as a macro. Now, what the header is doing under the hood, the Windows header, is it's looking at this and it's checking whether I'm working in Unicode or ANSI mode. So if I hover over here, I see that this has been defined as register class W, and I can make this explicit by something like if not defined Unicode define Unicode, and this is the definition that is being used to determine what function is actually being dispatched. Okay, cool. So here we've registered a window class. The next thing I want to do is I want to actually create the window. So again, this is going to return a handle to a window. So that's the data type there. I'm just going to call this window, and I'm going to use the create window function. I'm going to create window extended, and again we can see that this is a macro which is evaluated to Unicode window extended, and there's a bunch of things we need to put in. What is this? Style? I think that's extra style actually. Then the class name, so the window class that we're creating, the window name, which is the text which appears, the style of the window, X, Y, Z, X, Y, width, height, all that stuff. And yeah, so let's get into it. So I'm going to define 0 extra style modifiers, and then I'm going to just put in the class name that I defined above. And then for the name, I'm just going to say my window. And then for the style, I'm going to use this window style overlapped window, and this is just the standard window. We can drag it along, we can put it in front of other windows, stuff like that. Then we're going to need the X, Y, width and height, and for that I'm going to use this CW user default, and I can actually use those for all of them, all those size options. So X, Y, width and height. Then we're going to need the parent, and we do not have a parent. We are the main window, so we'll just put in null. The menu, again, we don't have a menu, so nothing. Okay, the instance of the program that we're basically connecting to, go ahead and put that in. And then the this LP param, long pointer parameters. So what we can do is we can specify an extra chunk of data, and that extra chunk of data can then be passed along to other things such as our callback function. But I don't have any extra data, so I'm just going to put null. And there we have it. A nice not too long line of code. And I'm just going to put in, say, do a check. So we'll say if window is null, we're done. We are done. Okay, cool. So now we have our main loop. So I know that, oh, sorry, one thing I forgot. I was going to need to show, and that's where I'll put in my appearance parameter. Okay, cool. So the loop. Now I know that I put a while true here, but I'm actually not going to go with that. I'm actually going to, in this loop, continually grab an event from the Windows event queue or message queue. So what I'll do is I'll have a blank message which will be populated. So MSG message, and again I'll just zero everything out, and then in here I'm going to call the get message function, and I'm going to pass in the pointer which will be populated with the appropriate message, and then the window. Now this bit here, handle window, is the exact window to wait on, but I'm just going to put null, which will wait for input from any window. And then we can also specify some filters. So messages are sort of, they're coded by unsigned integers, and within certain ranges we have certain classes of message. But I'm just going to put 0 for both of these, and this will just grab any sort of message. Now what this returns is if the message was basically a quit message, then it will return 0. If it's an error, it will return -1, but for anything else, it'll return some sort of number. Oh yeah, this is probably a good thing to talk about. If I hover over here, it says get message W, but if I look at get message W like that and hover over there, we see that it says it's going to return a bool, but in Windows programming, booleans are an alias for integers. So it's not really legit to assume that true is 1. False is 0. That's still true. True. Anyway, but true is just any non-zero number. So that's a bit of a trick to be aware of. Okay. So sort of psych, I got my event. So by the time we get to here, this will be populated. So what we can do is there's a function called dispatch message, and I'll just pass in my my message, and that will pass it along. Okay, so I think we probably have a minimum viable thing. So let's just run this and see what happens. We'll find out. Okay, cool. So we've got an error. Let's have a look at the error code that we're getting. Unresolved external referenced here, invoke main, something like that. Okay, cool. So what's happening here is if I right click on my project and go to properties, and I go right over here to linker and system, we have here the subsystem. Now, when I created this, I created an empty console app. And so this is expecting to run on the console. Now, the problem with that is this is sort of like when we have a library and we, link up the header file and we have the library file, but we don't tell the linker to use the library file. It doesn't know what to do. So similarly, we need to tell the linker that this thing is working within the Windows environment. And we can do that by going down here to Windows for our linker subsystem. And then we can go ahead and run this. Okay, now we've got a window. So what I can do is sort of, drag my mouse around, hit some buttons, and nothing happens, and that's fine because, again, my callback is not doing anything. So what I'm going to do now, hey, see that? I closed the window and it didn't tell the program to close. So that's pretty cool. So what I'm going to do is I'm going to handle some different things. So what do we have? A window message quit. Yep, that works. Okay. So in the case that we get a quit message, we actually need to post that message out so that the program actually knows that we're quitting. So the way we can do that is with this function called post quit message, and it's going to put in 0 for the exit code, and then return 0 because this function has to return something. So I'll go ahead and run that again, and now when I close, very interesting. Okay, oh my goodness. All right, so as I was saying, so right now we have our window, and when we quit, it's not actually quitting the program. And the reason is it should actually be the window message destroy that we're looking for. So now we can run this, and when we quit, we are actually quitting. All right, so I'm not sure if I mentioned this before, but I've also put in this translate message. What that's doing is if we get a key press or something that comes along first up as a virtual message, when we translate that into what's called a character message, and then put that back on the queue so we can get that event again. There's one more thing that I'm going to do, and that is, I guess, a draw event. So another message I'm going to handle is this window message paint. And in this case, we can do a few things. So going to create what's called a paint struct, and this is basically if you've done Qt or something like that, you'd have a concept of a paint event, and a paint event is basically which area we're painting and a bunch of other info. So that's basically what a paint struct holds. I'm going to begin painting on the window, and the way this works is we call the begin paint function. We stick in the window that we're painting to, and we stick in a pointer to that paint event. And what this does is it goes in, gets info about the window, writes that info out to the paint event like that, and this returns a handle to a device context. So I'll go, okay, HDC device context is given by that function there. Okay. And the next thing I'll do is I'll go ahead and fill the screen. So I'll go fill rect, and we're going to need the HDC, so we're going to put in our device context. Then we're going to need the rectangle, and the way we can do this is we can get that paint, oh my goodness, paint event. We're going to get its, RC paint, that's the rectangle. But it needs to be a pointer to that, so I'll just go ahead and get the address. And then the last thing we'll need is handle to a brush, and this is the color that we're going to put in there. So I'm going to make a H brush, a handle to a brush, and the way this works is we put in the color that we want. There's a bunch of different options here, but I'm just going to use a raw color. So I think this is color window. And then the trick is for all of these, if we use a an enum, like a raw integer value, for some reason, we always need to add 1. That's just how it is. That's what the Microsoft documentation says. So we've got that. And now we're going to finish drawing. So we'll go end paint. And we'll need to put in again the window that, the window that we're painting to, and the paint event that we just described, and that will apply that paint event to that window. Okay, then we'll go ahead and return 0. So go ahead and see how this goes, and we're going to get an error, and it's a very strange error. So it says there's no initialization of device context in the default label. And this is just one of those C++ oddities, I guess. But what I need to do is I need to make any local variables to this switch statement really sort of independent of each other. And I can do that by encompassing this with braces, and then it works. And just to prove that this paint event is working properly, we can go ahead and change that color. So we can go color, and then what's a color that'll really stand out? Gray text? Yeah. So if I run this, we're now getting a gray window. Okay, so it may not seem like we've done much. To be honest, we haven't done much. But I would rather take the time to go through the fundamentals of Windows programming before I go into the actual DirectX stuff. So there we have it. I hope you enjoyed that little light introduction. I know my program isn't going to win any awards, but that's very cool. So, as always, you know, all the best, and I hope to see you again soon. Bye. Hello! I just want to give a quick little shout out and thank you to all of my channel supporters. I'm community fund. That's a tough word. I'm community funded. It's how I keep the lights running. Not really, but you know, it's how I... So I really appreciate any and all support. If you can't support financially or don't want to, look, that's totally fine. It's not expected. It's sort of a premium subscription thing. In that case, the best thing you can do to support the channel is to comment. Let me know what you're liking, what you're not liking. I know I do a bunch of things, but I am trying to make the best educational content that I can. So, big thank you to Antonin Carret, Dankil Foles, Declan, Enderlon Studios, Isaiah Meyer, Jason Coleman, Mathieu Derick, Moim, Shreyar, and Maxim Shukim. Thank you so much, my dudes. It really does mean a lot. Yeah, cheers. Have a gonna get hit. Have a good one, and I'll see you again soon. Bye.